Hello, everyone, and welcome to my talk at the India Azure Community Conference. I hope all of you have been having a blast attending all the interesting talks so far. One of them that particularly caught my eye was the one that talked about deploying micro front ends. I think that shows as to how far we have come in the space of technology. So, without further ado, let's get started with the talk. Before we start with the talk, I just want to do a quick introduction of myself. My name is Gnana Lakshmi T C, and everybody loves to call me Gyan. I work as a product manager for emerging technologies at Wiley Next. Apart from my daily job, I also love to volunteer for different roles just so that I can learn and grow. I volunteer as an ambassador for various blockchain foundations such as Algorand, Eternity, Polkadot, as well as the Near India Guild. I also volunteer as the city director for Women Who Code Bangalore, where we aim to help more women to get into the technology space. What is my today's talk all about? Today, I'm going to be talking about how you can simplify blockchain with the help of cloud technologies. My today's agenda is completely focused around blockchain and how cloud can be a pivotal change in the space of blockchain. I'll introduce the idea of blockchain, share a small blockchain demo, give a technical deep dive on the various components of blockchain, talk about the different types of blockchain briefly, and then, of course, the most awaited topic, blockchain and cloud. Post that, we'll have time for a short Q&A. Before I show you what blockchain is and get into the technical elements, I think it is very important for us to understand as to why now and why blockchain, right? So here is some short information or a small survey result from Gartner, right? So as we see this result, it talks about how from 2009 to 2020 onwards, it was all about enabling the technology. Post 2016, there were a lot of solutions inspired by the concept of blockchain. And as we speak today, we are in a trough of disillusionment. That is, we are working to try to find out a lot of real use cases and experiment if they work well with our current industry scenario or not. As we move forward in the further phases, we are going to have complete solutions deployed end to end in enterprises as well as startups. And as we move to the next phase, there are a lot of research that is going on right now that will help enhance the existing solutions. So towards the end of if you see towards the end of the era, if I talk about, we are going to have programmable economy based on blockchain. This chart or this graph gives us a clear idea of how blockchain has innovated since the beginning of time of blockchain, that is around 2008 2009, right? Initially there were blockchain managed services, and then there was a big hype about the decentralized web. Starting from that hype is where you can see a huge curve going up, where at the top we can see that there are a lot of blockchain platforms, cryptocurrency hardware wallets that came into picture because of more and more demand for blockchain. And then there were software wallets. And as we speak about the trough of disillusionment, right? Now we have exhausted all the research and now are in the space where we are working and trying to build more and more real-time use cases. And of course, as we go further down the line, the number of use cases as well as the number of solutions that are going to be deployed in the industry are only going to increase exponentially. Therefore, now is a great time to learn blockchain because it's a niche skill. And as we become experts in these niche skills, going further, our demand and the demand for our expertise will increase exponentially. This is just one piece of survey, but if you take a look at the different surveys, talk to the various companies who are actually using or trying to use blockchain, you will see that being able to learn blockchain, being able to work with blockchain is becoming more and more of an important skill. So without further ado, let's get started to understand what is blockchain and what is the origin story. So in the year 2008, when there was a great financial crisis, that's when people started to doubt the centralized system of finance, right? Because huge investment banks like Lehman Brothers declared bankruptcy during the great financial crisis. And a lot of people who had put their trust on these institutions started doubting these institutions, whether it is worth investing the money in a centralized institution. And that is where the idea of a decentralized financial ecosystem came about, when a paper known as Bitcoin, a peer to peer electronic cash system, was released in the year 2009 by an author or a group of authors known as Satoshi Nakamoto. This is the first ever paper that solved the double spending problem with respect to the digital currency. There was a lot of research that was going on in this space, where researchers were trying to understand that how they can make the digital currency safe in such a way that they can avoid the double spending problem. And this paper came out as a great solution for that problem. The underlying technology behind this paper is what is known as the blockchain technology today. This paper talks about a purely peer-to-peer version of electronic cash that would allow payments to be sent directly from one party to another without the need for a third-party institution or a third-party financial institution specifically. The principles behind this paper were so strong that enterprises, startups, and all the folks, technology enthusiasts across the globe started doing more and more research and trying to understand how we can use the underlying principles behind Bitcoin to create robust solutions in the space of technology. As we go through this talk, what you want to try and understand, or let's say if you want to implement a solution, build a solution on top of a blockchain, these are a couple of questions that you should be able to answer before you dive deeper into the field of blockchain. The first and foremost is, what is a blockchain network, right? The second, how can you become a part of the network? And the third, and one of the most important questions, is what is a ledger? These three questions form some of the core concepts underlying blockchain, and as we go through the talk today, you will be able to explore each of these concepts in depth. Let's start with the first one. What is a blockchain? And then we will move to what is a blockchain network. Blockchain is nothing but a decentralized database where information about various transactions is present. As I start explaining blockchain to you, what I would request you is to keep a financial sort of background in mind, where transactions right now mean financial transactions. But as we go through the talk, you will also understand that transactions are not just financial in nature on blockchain. But to start with, it would be easier to have a financial transaction analogy to whatever I'm talking about in the space of blockchain. Blockchain has several advantages. Some of them are that it is really hard to tamper with the data that is present inside a blockchain. And another advantage, which is significantly used in domains like supply chain or finance, in fact, is that blockchain can be used to establish provenance. What is provenance? Provenance is the ability to track the beginning of the object. Basically, if you think about the life cycle of an object, where the object originated, where the object is right now, and where the object might be in a couple of days, right? The ability to find out the origin of that object is known as provenance. And blockchain helps us establish provenance, as well as one of the other significant advantages of blockchain is that it is really hard to tamper with. Overall, we can summarize that blockchain is nothing but a decentralized database which contains information which is hard to tamper with. Let's talk a little bit more in depth about what is blockchain, right? Blockchain consists of a set of transactions. This is something that we already saw in the previous slide. It contains information, which is nothing but a set of transactions. But how are these transactions represented in a blockchain? The transactions in a blockchain are clubbed together and combined into one single block. Now, blocks like this connect with each other and form a chain. And this whole chain is known as blockchain. If you're familiar with programming, we have a concept of linked list where there is a huge list and each element of the list is linked to each other through pointers. In a similar manner, in this case, each block is related to the next block using hashes, cryptographic hashes. Blockchain is open source and it is immutable, right? So the idea of creating an open source technology is to raise the level of trust that participants have in the network, right? Now let me answer the first question over here. What is a blockchain network? A blockchain network is nothing but a connected set of peers who are a part of the blockchain, right? And they are the ones who can perform transactions with each other. So a network, as for example, we have the World Wide Web, and where internet is our network, a global network. Similar to that, a blockchain network is a set of peers connected to each other, who are all connected to the same blockchain specifications. We'll also see a little bit more about the immutability or the ability to keep blockchain safe from tampering, right? It's also known as a distributed ledger technology. So let's go back a little bit to this image, right? If you focus on this image, like I said, the blockchain network is peers who are connected to each other through a network, right? Which has a common set of specifications. And the concept of a ledger is nothing but information that is present with everybody. So all the transactions that take place on the blockchain are stored on the ledger. And this ledger is present with everyone who's a part of the network. A copy of this ledger is present with everyone who's a part of the network. So if you see this image, you can see that the ledger has several transactions that Dave has done, Alice, Bob, etc., right? And if you see, the same copy of the ledger is present with everybody who is a part of the network. And therefore, blockchain is also known as the distributed ledger technology, if you see it, right? And you might also hear the terminology DLT a lot in context of blockchain. That is nothing but distributed ledger technology. This also makes it a very strong candidate for situations or for use cases where a lot of open source or a lot of information transparency is required, because the same information is available with everybody who is a part of that particular ecosystem. Decentralization, right? I have this word and I have a exclamation mark in front of this word, because decentralization is one of the most significant properties that blockchain offers and is one of the most important properties that is being talked about in the context of blockchain. Decentralization is the ability to remove a third party from your ecosystem and ensure that the network itself has some underlying components that establish trust between people who are a part of the network. The initial problem that we started out with, the great financial crisis, was that everyone across the globe trusts a centralized ecosystem for handling their financial money, right? For handling their financial transactions. But blockchain came into picture showing that financial transactions can be handled within an ecosystem, within a network, without the need for a third party to intervene. The open nature of blockchain itself is seen as a form of governance. Let's take a sneak peek into how blockchain actually works. If you're able to see my screen, you have seen the different components of blockchain and you have heard a lot about what a blockchain actually contains, right? Now let's see it in action. If you see this picture, you can see that here I'm representing what a block of a blockchain looks like. So each block has a unique block ID that is associated with the block. So here you can see that the block ID is number 1. It also has a nonce that is used to identify this block in a blockchain. It is also used in a consensus protocol named as proof of work. Proof of work is the consensus protocol which is used by Bitcoin. I'll talk about consensus protocols a little later, but nonce, I would say, is a random set of strings, a string which has random numbers put together and which is unique to each particular block again. Now the data in a block is nothing but a set of transactions, as we already saw, set of transactions that are clubbed together. So for example, transaction 1 is that Dave gave 17.5 Bitcoins to Alice, right? Now, of course, the transactions will not be in this format. There'll be a transaction hash that will be present here, right? But I'm just, just for the sake of understanding, I'm writing the transaction like this. So suppose there is another transaction where Alice has, say, for example, transferred 20 Bitcoins to Bob, right? Here again, originally, it will be represented by a transaction hash. So if you see like this, there'll be a lot of transactions that have happened on the blockchain. It will all be collected and put inside a block. A hash will be generated for all the data that is present inside the block. Now, when I click on mine, what will actually happen is, if you see, the color of this block has turned green. What that means is this particular block is now available as a part of the blockchain. So if you see the blockchain as to how it looks, we just now saw the structure of one block, right? Now you can see that there are multiple blocks which are all connected to each other, and these are the ones that together form a blockchain. So you can see each of the blocks has a block ID, a nonce. It will have some data, of course, right? And now you will see there are two sets of hashes. As I mentioned earlier, in a blockchain, the blocks are connected to each other using cryptographic hashes. So here you can see that block 2 has the hash of the previous block. Block 3 has the hash of the previous block, that is block 2. Block 4 will store the hash of block 3, and so on. This is how the blocks are connected to each other. So each block not only has its own hash that is related to its data, but it also has the hash of the previous block. The first block in every blockchain is known as the Genesis block, and as it does not have a previous block, its previous hash will just be 0. Now, let me talk about an important property of blockchain that I have been harping on since the beginning, that is immutability, right? How do you ensure that you cannot easily tamper with the data that is present in the blockchain? So if you see my screen, if I try to type some data, the hash of this data will change drastically, right? Because the hash is completely dependent on the data that is present in your data section. So if I say initially that the transaction is, say, Dave sent 10 Bitcoins to Alice, right? But if I try to, and if I mine this block, of course, then this block gets added onto the blockchain. That means this particular data is now recorded on the blockchain. Now, if I try to change something over here by adding a 0 or by trying to remove a 0 or trying to tamper tamper with the data that is present in the block, you see that this block has turned red. What that means is the hash of this block has changed drastically just because I made a small change. So if you see, the initial transaction that I had was 10, and the hash of this block is starting with 4 zeros, D2BE right? Now, if I just remove this 0, the hash of this block becomes 5F0E60. So this is not even anywhere close to the previous hash that we had. So every time anybody tries to tamper any information in the blockchain, the hash of the blockchain changes drastically, thereby confusing all the blocks that come after this block, because the next block is meant to store the hash of this block. The next block is meant to store the information of the earlier block, and so on, right? So the moment we try to tamper with any one block, all the blocks following this block get confused and start showing or start raising the alarm that something is not right. And this is where blockchain comes into picture when you talk about tamper-proof information. In our current database system, whenever we try to enter information regarding whether it is financial transactions or regarding tracking of an object, right, or any other information that is very crucial for that matter, it is very difficult to make it tamper-proof unless and until we attach a lot of cryptographic related constraints on the database. Even then, an admin who has a password to the database can easily crack it open. This is where blockchain comes into picture, where it is really, really difficult to manipulate data once a block has been added to the blockchain. Let me quickly show you what the distributed ecosystem looks like, because we have already seen that the ledger or the information is distributed across or parties who are a part of the blockchain. So if you see peer A sees the same blockchain as peer B and peer C, and so on. So everybody who's a part of the network will see the same data being reflected across. And when any change is made in one local copy, all of the others need to know that this particular change, whether this particular change is valid or not. If it is not valid, then this change cannot be accepted by the ecosystem. This is what makes blockchain tamper-proof and immutable in nature. So now that we are through with the blockchain basics, a little bit of the basics, of course, introduction, I would say, as well as some information through this demo, let's go back and see what more information do we have to offer. All right. The next thing to understand is how transactions are processed in a blockchain. The image that I have in front of me talks about a simple blockchain transaction in context to Bitcoin. So there are 5 steps to how a blockchain transaction is processed. When A wants to send money to B, right, the transaction is represented online as a block. So as we all know, the moment a transaction comes in, it becomes a part of the block. Post that, the block is broadcasted to every party in the network. This is true in case your blockchain is a public blockchain. Post the block is broadcasted to every party in the network, then those in the network will approve the blockchain by doing some verification behind. Once the block is approved, once the transaction is approved, then that particular block, which has other transactions as well, right, is added to the chain, thereby creating an indelible and transparent record of all the transactions that have happened so far in the blockchain. Only once the block is added to the blockchain, money can be moved from party A to party B. So the 5 things to remember when it comes to a blockchain transaction is transaction, a block, verification, creating a hash by creating a block, and executing that particular transaction. Now that we have looked at some basics of blockchain, right? I'm sure you must be having two major questions about blockchain. The first is, of course, how is blockchain immutable, right? I think this is something that we already saw in the demo, that the blockchain is immutable with the help of cryptographic hashes and how the blocks are linked to each other. The second, and again, one of the most important questions that you must be wondering about is who selects the next block? How do the blocks get added to the blockchain, right? Well, let's see the answer. The answer to this is something that I already mentioned, and a very core computer science concept known as consensus protocol or consensus algorithms. As the name itself says, consensus is nothing but a way to come to an agreement, right? So, in a blockchain ecosystem, there are a lot of peers or a lot of parties who are interacting with each other. Now, we are saying that we are removing the centralized third party, but still ensuring that there is trust between all the parties who are a part of the network. Now, what does that require? That requires some kind of algorithms, some kind of underlying settings from our end, which is agreed upon by all the folks in the blockchain ecosystem. These set of rules that define as to what is the core functionality of a particular blockchain network that has attracted everybody to join that particular ecosystem or join that particular network is known as consensus protocols or consensus algorithms. The consensus protocols broadly fall under two categories. The first one is known as proof of work, and the second one is known as proof of stake. Proof of work is a very old consensus protocol and has been implemented since the era of Bitcoin, right? What is proof of work and what does one have to do in this consensus protocol? In proof of work, to add each block to the chain, the miners, so miners are specific entities who are required to solve a particular puzzle, a cryptographic puzzle, using their computer's processing power. So when I was showing you the demo, I'm sure you must have noticed that the mined blocks had a particular hash and the hash had a pattern associated with it. So if you saw, there was a hash that had 4 zeros starting and then some sort of string, right? Now, that is an example of a problem that a miner needs to solve. For example, generate a hash which starts with 4 zeros. So, and as the number of participants in the network keep increasing, this computational problem also keeps increasing exponentially. So, in the proof of work, each miner must compete, or rather, the ecosystem of miners must compete to solve a difficult puzzle using their computer's processing power. In order to add a malicious block, they would have to have a computer which is more powerful than 51% of the network, because you need to convince more than 51% of the network that the data that you're adding is valid. The first miner to solve the puzzle is given a reward for their work. In the Bitcoin ecosystem, they generally get Bitcoins for solving a puzzle successfully. Now, the problem with proof of work is that there was a lot, not was, in fact, there is a lot of computational power that is being utilized just for solving this puzzle. And because of this, in the ecosystem, there is a negativity towards the whole concept of blockchain. Why? Because everybody started investing a lot of money in just setting up solar farms or electric farms, electric powered server powerhouses, just to solve this computational puzzle, because everybody wanted to earn bitcoins. But the idea of the blockchain system is not to just have bitcoins or rather cryptocurrencies, but it is to be able to solve complex problems that arise in the industry where this cryptography and distributed ledger system can efficiently solve these problems with the help of technology, right? And that's where the proof of stake algorithm came into picture. Proof of stake is a consensus protocol where there is no competition or there is no concept of miners. Why? Because the block creator, that is, whoever adds the next block, is chosen through an algorithm based on the stake of the user. So, what that means is the more stake you have in a particular blockchain network or in a particular ecosystem, the more likely it is that you will be selected to choose the next block. What this shows is that if you have more stake, that means you would want that particular blockchain ecosystem to succeed. Otherwise, if you and you would not end up doing any malicious activity, right? Otherwise, if you end up doing any malicious activity and you have more stake in the ecosystem will fail, and therefore your stake will be worthless. And this is the idea of proof of stake, that the more stake you have in an ecosystem, the more you believe in that ecosystem, and the more you will ensure that malicious activities do not take place in the ecosystem. In order to add a malicious block in this ecosystem, you would have to own 51% of all the cryptocurrency on that particular network. That is, you will have to own 51% of the stake in that particular network. In this particular consensus protocol type, there is no reward for making a block. So the block creator will take a transaction fee. So there is no minor concept here, right? So you're not getting anything back. So because you are doing some effort, you're doing some computational effort to add a block, right? You get a transaction fee. Now, I just want to quickly talk about some of the advantages, of course, of using blockchain, right? Um, it's open source, everyone can add to the database. It is peer-to-peer storage, that is, everybody in the ecosystem has a copy. It is real time, that is, every time a transaction happens, it is auto-synced across all the folks who are a part of the network. It is permanent. The information that is present is mostly permanent because it is tamper resistant, right? One should never say that the information cannot be changed or it cannot be deleted. It can be done logically speaking, right? But practically doing it is really difficult due to the complexity of the blockchain and the number of blocks in the network itself. There is self-ownership of data because you can choose to hide the data that you don't want to show through some cryptographic practices that are implemented in the identity management use case. And you can choose to share only data that you want to share with different parties in the ecosystem. So this is where blockchain can act as an added advantage when it comes to self-ownership of data. So, as I mentioned in the agenda, we'll take a look at the different types of blockchain that exist as of today, right? I'm sure there are going to be more and more that are going to be popping up in the future years. But even if more of them come up, they will all be based loosely on one of these types or a mix of one of these two. So the first and the foremost blockchain that ever came into picture was public blockchain, that is Bitcoin, right? The idea of public blockchain was that it is available to all. Anybody can join the network. Now, I know that in the beginning, when I shared with you 3 top questions, I only answered the first and the third one. What is a blockchain network and what is a ledger? The second question was, how can I join the network, right? In a public blockchain, anyone and everyone can join the network seamlessly just by creating an account. An account is nothing but, for example, when you go and create an account on Microsoft, right? You give some credentials, and then your account just gets created. Similar to that, in a blockchain, you create a wallet for yourself, where you get assigned a hash address, which then represents you on that blockchain network. So, in a public blockchain ecosystem, because it is available to all, anyone can join the network seamlessly. Another type of blockchain network is private blockchain network. Now, why did private blockchain network come into picture, right? Because there were a lot of enterprise solutions that required that the data that they're working with should only be shared between specific parties, because the data is extremely sensitive and confidential. In that case, we cannot just allow anybody or any outsider to join the network and be able to get all the information about that particular organization, right? That's where private blockchain came into picture. Private blockchains are available to only those who are a part of a particular private network. So, certain organizations can create a network amongst themselves, and the data that they work with is only specific to their use case, and it is available to only those who are in that network. Network access, that is, ability to join that network, is restricted by the different membership rules that are underlying that network. Some examples of public blockchain, famous public blockchains are Bitcoin, Ethereum, Algorand, Eternity, right? One of the most famous examples of private blockchain is Hyperledger Fabric. Then there is Corda. Corda Ledger is also becoming more and more popular, right? And now there is an interesting sweet spot between public blockchains and private blockchains, which is known as the consortium blockchain. Consortium blockchains, which are fairly recent, are semi-private blockchains. That is, the blockchains are not open to everyone, but it's also not restricted to a particular use case between just few organizations. Several organizations decided that, hey, we have common use cases. Why don't we work together, right? And put some stake in this particular technology and build a consortium which will address these problems that are there in this particular use cases. So the organizations form a consortium, right? And multiple organizations have a stake in the outcome that the consortium is building. One of the famous consortium examples is Quorum. Quorum is an extension of Ethereum itself, but it is a consortium blockchain where a lot of enterprises have stake in how that blockchain will shape up. An interesting observation when it comes to consortium blockchains is that it is such a beautiful concept because it doesn't allow all the public to just join the network and be able to play around with the value of the network, but at the same time it doesn't restrict the network to just a few parties, right? So a lot of us can see how the consortiums are progressing through the reports of the consortium, through what the consortium is doing, through the updates, etc. So that's what is interesting about consortium. And of course, a lot of big organization enterprises have a stake in the blockchain ecosystem itself, which is super exciting. So let's take a look at what are the components of a blockchain application. We have been talking about blockchain so far. Let's talk a little bit about blockchain application, and then I'll close with how cloud kind of comes into picture, right? So what are the different components of a blockchain application? From what you have heard so far, I'm sure you will be able to answer this yourself. The first one, of course, is the ability to launch and manage the entire network, right? The second one is working with smart contracts. So what are smart contracts, or essentially what do you need to do in an application? You need to codify your business logic and create an application out of that. Now, being able to codify this business logic or write this business logic in blockchain is known as smart contracts. So smart contracts are nothing but similar to your programs which contain your business logic. So of course, first you need to launch the network, then you need to write the logic, right, for your business, for your use case. And then you need to build the application and be able to extend the application to the others, be able to extend the application to add the different use cases, different corner cases that come in your blockchain application. These are some of the important components of your blockchain application, right? And this is where cloud actually comes into picture. So there are certain challenges when we think about these blockchain applications and their deployment, right? Of course, as we all know, the first one is scalability, right? The ability to scale a blockchain application is extremely difficult because a lot of applications are still based like on proof of work. So if you use a blockchain that is based on proof of work, then you need to wait for a longer time for your transaction to come through. And having more and more people in the network can mean that there is, you're not able to handle the scale of transactions that is happening in a network. So scalability is definitely one of the challenges. Increased costs. If you have to do everything on your own, you have to invest a lot to ensure that you're able to maintain the network, you're able to launch the network properly, debug the errors, etc. And then in order to manage the consortiums themselves, you require special skills as well as administrative abilities to manage the whole ecosystem. And as I said, this is where cloud comes into picture. Cloud has made our lives so much easier when it comes to deployment of blockchain applications, right? Here are some glaring advantages that cloud gives us when it comes to blockchain application deployment. There is low cost access to technology. You don't have to worry about maintaining your network, launching your own network, deep diving into understand how to set up the different peers and how to ensure that everything is working properly, right? You need to not only spend man cost, but also you need to spend the cost to maintain the whole network, the related server and all the related components, right? Whereas if you use a blockchain as a service from any of the cloud providers, for example, the Azure Blockchain Services, right? You just get all of these network, the peer, and several other related things at a very low cost. It offers massive scalability. Scalability has been one of the biggest challenges when it comes to blockchains, and cloud has ensured that scalability can be offered by ensuring that we can create more and more peers, more and more logic, and scale our application with the help of other tools and dev kits offered by a cloud platform, right? Increased data security, simply because every cloud platform, especially platforms like Azure, already offer inbuilt data security features. And therefore, it's not just blockchain that is securing your data, but even the other components related to your blockchain application are highly secured with the help of cloud. And most importantly, you can access anywhere. You don't have to always worry about running the node on your local host or on your local computer. Once you have it running on cloud, you're able to access it from anywhere, and your application is able to access that particular node or peer from anywhere. That's the beauty of being able to build an application, blockchain application, on top of cloud. And of course, better software, right? You not only get the blockchain application service, but you also get multiple other connected things that makes your application quality better overall. So the Azure Blockchain Service is one of the interesting services that is provided by the Azure cloud. Let me see if I can just quickly show you. So if you see this, this is the Azure Blockchain Service, right? If you just go to the Azure website and search for the blockchain service, you can see that there are several things that the service talks about: how you can create your own members, how you can create your data manager, There are also various metrics that you can read from your blockchain using this Azure Blockchain Service. So let me show you, if I can just quickly show you one of my deployed members, right? So as you see here, I have already deployed a service, right? I just wanted to show you the metrics part. So here is a member that I actually deployed using the Azure Blockchain Services, and see the beauty of this, right? Here you can see several metrics like pending transactions, process blocks, process transactions, queued transactions. All of these metrics can be seen in the form of graphs when it comes to all the transactions that you have made using your Azure blockchain service. Now, typically doing this on your system or on your local system would require you to write multiple levels of scripts and require a lot of skill and understanding, right? Over here, you have the ability to just click, on one click, you're able to see in-depth information as to how your application is performing. And this is actually a game changer for those who are in the space of blockchain. So quickly talking about the different the different aspects of the Azure blockchain service, right? One of the most important is the built-in consortium management. Like I said, consortium management is an extremely difficult and challenging work. But because there is built-in consortium management, if you noticed in my previous demo slide, that my service is already deployed in a consortium that I created, right? And I chose the default consortium to be Quorum over here. So if I show you the overview, yeah, so you see that I've created a resource group using the protocol Quorum, right? And I've created my own consortium called India Azure Conference Trial. So you can also create your own consortiums that way and manage the different members who will be a part of the consortium. There is easy blockchain data publishing as well as metrics that you can see easily that I just showed you. Open and extensible design. One of the important things about Azure is that it offers a lot of useful dev kits that can go along with your blockchain application. So you can design it in a way, you can design your application in a way that you can use the things from the dev kit and plug and play wherever it is required in your application. So Azure Blockchain allows you to build and extend the application. So you not just build an application, but you're able to extend the services that the application offers. You're also able to model smart contracts, that is your business logic, right? Using VS Code. So VS Code, there's a VS Code plugin where you can author, write, and test your own smart contracts. And you can launch and manage the network, of course, right? Just now, as you saw, using the Azure blockchain service. So one of the important things that I want to be the takeaway from this whole talk is that cloud has come into the picture because there are several challenges when it comes to building blockchain applications and deploying them, right? And services like the Azure blockchain service comes with a lot of advantages, especially when it comes to management, as well as being able to build the components together into a seamless application. So the days of just writing POCs or individual smart contracts are gone. Now we are trying to build end-to-end applications. And that is when we have to look at services like these and what they offer, so that we can not just build a small POC, but also extend the application to such a way that it is scalable and robust in nature. So to close, of course, I want to share the different use cases that blockchain has. So why I put up this slide is just to show you that you don't have to be stuck to just one industry like finance or insurance or identity management. There are use cases in every industry that you can come across in the space of blockchain. For example, supply chain. If you want to track the product from its origin to where it is being sold, right? You can definitely use blockchain here. IoT, if you want to monitor the information that is coming from devices, right? If you want to use, if you want to do grid monitoring, then blockchain can be a great use case. If you think about media, then if you want to reduce ad click fraud, right, then that's where you can kind of use blockchain to ensure that the data is not being tampered, right? That you have real time data. Of course, in the medical and the healthcare ecosystem, in order to save the records and have a tamper proof system of records, medical health records, lot of research is being done in this area as well. So there are several use cases in various industries that you can see in the space of blockchain, and there's a lot of scope for you to explore and see which of these industries or domains that you're interested in. And now that you are familiar with what is blockchain, how can blockchain actually act as a solution to certain problems in the domain of your choice? So to close the talk, I would just like to thank the sponsors, Microsoft, and the DevOps partner. Right, I'm super thankful to the India Azure community for giving me this opportunity to be able to present my idea and my thoughts in this space. Of course, I'm also part of the community Women Who Code, and love to thank once again the India Azure community for helping more and more women to kind of come forward and share their expertise in the space of technology and have a conversation, right? So of course, super excited to see all these communities come up and see what they're doing, the interesting work that they're doing. And most importantly, I am happy to connect if you have any questions in blockchain, want to talk to me about technology. So I not just work in blockchain, but also in the space of AI, and I'm starting to deep dive in the space of quantum as well. So happy to have any chat in the space of emerging technologies as such. Here is my LinkedIn. Feel free to connect with me. And I hope you're all going to be looking forward to the other upcoming talks as well. I'm definitely going to be attending the one that talks about machine learning for .NET developers. Very curious to see what's out there. And hope you all had a great time listening to my talk. And of course, enjoy the rest of the conference and have fun. Thank you.